Unit is on two-dimensional motion. There are four main topics that we'll cover: vectors and a trigonometry review, the right triangle trigonometry that you learned in math, projectiles that are horizontal, projectiles that are not horizontal, and circular motion. We'll start today with vectors and a review of right triangle trigonometry. So why are we doing vectors? Well, in physics, we can only deal with one dimension of motion at a time. And so when we've had, a car that was driving, it had one dimension. When we dropped things off a cliff and they fell straight down, that was one dimension. But now we're going to start having things that move in two dimensions at one time. So we're going to throw a ball into the air and it's going to have a path that looks like this. So it'll go up and down, but it'll be moving sideways at the same time. Things that move in circles are moving in two dimensions. And so in order to deal with a two-dimensional problem, you have to divide it into its component parts, its part in each dimension. And vectors allow us to do this. The word components, well, for anything, a component is a part. And so if I have a velocity that is in this direction, that velocity is made of velocity that is in this direction and another part or component that is in this direction. These are called the x and the y components of that velocity. Now, any quantity that's a vector quantity can be expressed as a vector and divided in components. The quantities that we've had so far are force, acceleration, velocity, and displacement. There will be others that come later. Primarily in this unit, we're going to be dealing with velocity vectors. So if we take our vector and we break it into its parts, that's called resolving it into components. I apologize for my handwriting. I am using a different tablet and it's a little more difficult. And that word is resolve. R-E-S-O-L-V-E. Now when we take those component parts and put them back together, add them up, then we get the resultant. And the resultant is the answer when we add that's bad. When we add vectors. So the first thing we need to do is learn how to take a vector and break it into its component parts. Resolve a vector into its components. Do you remember your right triangle trig? How would you find this side, which would be the x component, and this side of that right triangle? Well, if you know the angle and you know the length of the hypotenuse, then you use your trig functions. Remember the definition of the sine of an angle is opposite over hypotenuse. So the sine of that angle would be the y component divided by the velocity vector. And the cosine of that angle would be equal to the adjacent over hypotenuse, or the x component, over the hypotenuse. So if we want to solve for the y components and the x components, then we just do a little bit of algebra, multiply both sides by v, and we get vy equals v sine theta, and vx equals v cosine theta. It's a little bit neater, not much. Okay, so the x component will be our adjacent side, so it will be associated with the cosine. The y component will be the opposite side, and it will be associated with sine. So if we know that velocity and we know the angle, find the sine of the angle, multiply it by the velocity, and you have the y component. Find the cosine of the angle, multiply it by the velocity, and you have the x component. So let's say that this velocity was 10 meters per second, and this angle is 30 degrees. Find the x and the y components. All right, so Vx will be v cosine theta, or 10 times the cosine of 30. Make sure your calculator is in degrees for this unit. Some of you that have math classes might have to have it in radians for your math class. You must have it in degrees. Cosine of 30 is 0.866, so that's going to be 10 times 0.866, which will be 8. I'll just round a little bit, 8.7 meters per second. This was a velocity. It was meters per second. Its components will also be velocities with meters per second units. And Vy will be V sine theta, and that'll be 10 times the sine of 30. Sine of 30 is 0.5. 10 times 0.5 will be 5 meters per second. And that's all there is to it. So resolving our vectors into components is very simple. Finding the resultant. If you have the components, if you have Vx and Vy, well then how do you put them back together to find V? Well, you have two sides of a right triangle, the two short sides. How do you find the hypotenuse if you have two sides of a right triangle? Hopefully you've answered that question, and it's Pythagorean theorem. Thought I would get better at writing with this new tablet. I'm not. Now you write Pythagorean theorem as probably, I'm guessing, a squared plus b squared equals c squared. Well, I'm going to suggest that instead of writing it like that you write it as c equals the square root of a squared plus b squared. And this is a plus sign, not a dot. And the reason for that is when you're solving for c here, it's very typical for students to square a, square b, and add them, and then forget to take the square root. And so they get the wrong answer. But if you write it like this, that big square root sign is right there telling you to take the square root. Well, if you have this length, and we would if we did the Pythagorean theorem, do you know how to find that angle? Well, if I know all three sides of a right triangle, then I can really use any of the trig functions to find the angle. But the one that we use in this class most often is tangent, because we know that the tangent of that angle is equal to opposite over adjacent, right? So here's the opposite side, and here's the adjacent side. So it's the y component over the x component. If I know that the tangent of that angle is y over x, then I know that the inverse tangent, you have a button on your calculator, inverse tangent of y over x will give me the angle theta. Let's say Vx is 75 meters per second. So this side is 75 meters per second. And Vy is 40. So this side is 40 meters per second. Find the magnitude and direction of the velocity. By magnitude, it's find the length of this side. And by direction, it's find the size of that angle. So if I need the length of the side, okay, I'm going to rewrite the Pythagorean theorem using meaningful letters. We're finding the resultant, so we call the magnitude of the resultant r. And we have the x side and the y side. So instead of a squared and b squared, we're going to say the magnitude of the resultant is the square root of vx squared plus vy squared. Same Pythagorean theorem, just with meaningful letters and not ABC. Okay, so the resultant is the square root of 75 squared plus 40 squared. Let me grab my calculator. So 75 squared plus 40 squared, and then take the square root of that, and I get 85 meters per second for the resultant velocity. Now that's the magnitude, I need the angle. To find the angle, I'm going to use the fact that the inverse tangent of my y component of my x component will give me my angle. So I'm going to do inverse tangent of Vy is 40 over 75. So you take your calculator and you say 40 divided by 75 equals, and then inverse tangent, and I get 28 degrees. Okay, so we have taken a vector and resolved it into its components. We have taken the components and put them back into the vector, found the resultant magnitude and direction. Some more practice. You can swim 5 meters per second in still water. A river flows east at 10 meters per second. If you jump in and try to swim straight across, what will your velocity as seen from the shore be? So you have a river, and the water in that river is moving this way at 10 meters per second. It's a pretty fast river. It looks like 16, it's 10. You, as a swimmer, are going to try to swim straight across the river. You have a friend on the other side, and you're going to try to swim to your friend. And your speed in that water is 5 meters per second. Now, do you see that every second you're going to be moving 5 meters this way, but the river is going to carry you 10 meters this way? So instead of going straight across to your friend, you're actually going to have a path that looks like this. You're going to end up down here someplace. So your actual velocity with respect to the shore will be something like that. So we have the components of the vector. We have the y component, and that would be your velocity. And we have the x component. That would be the river's velocity. And we're going to put them back together to find the magnitude and direction of the resultant. So remember, the magnitude of the resultant is equal to the square root of vx squared plus vy squared. And that equals the square root of 5 squared plus 10 squared, or let's do it in the right order, 10 squared plus 5 squared, doesn't really matter. 10 squared plus 5 squared. 10 squared is 100, 5 squared is 25, so we want to find the square root of 125, and that's 11.2. Now the direction, inverse tangent of the y component over the x component equals the angle, and that'll be inverse tangent of our y component is 5, our x component is 10, so inverse tangent of 0.5 gives me a 26.5, I'll just say a 27 degree angle, equals theta equals 27 degrees. Okay? Second example, you walk 5 miles at an angle of 45 degrees north of east. So that'd be like if you had a grid like this. Sorry, my lines aren't straight. 45 degrees north of east. So this would be east. This is north. So you're walking in this direction, north of east, at a 45 degree angle. So here's, pretend that's 45 degrees. Okay, at a 45 degree angle. How far, let's see, if you had to walk only east and north, how far would you get, how would you get to the same place? So if you could only walk either north or east, you couldn't walk northeast, then you would have to walk east this far, and you would have to walk north that far. So we need to find the x and the y components of that displacement. Not a velocity this time, but it's the same process. Not v, displacement, so I'm going to call that d. dx is going to be d cosine theta, and dy will be d sine theta. So that will be 5 miles, 5, times the cosine of 45, and then 5 times the sine of 45. Now the thing about 45 degrees, the sine and cosine are equal. They're both 0.707. So the components here are going to be equal. So I'm going to say 5 times the cosine of 45. And I get 3.5. And it'll be the same for both. So 3.5 and 3.5 miles. Okay, so if this had been a 45-degree angle, if it split this 90-degree angle, then you would see that the components are equal and the components are 3.5. Okay, so now we've done an example of each type of problem, and I hope you're confident with both resolving a vector into its components and adding the components to find the resultant.